Just a reminder too about scheduling going forward. I know today is a little bit longer lecture than we typically have, and we're also lecturing quite a bit tomorrow. As such, Monday, Tuesday next week are going to be largely lecture free to give you time to do the work for this. Although Scott said he might do some sort of review lesson based on what people need. Okay. I was going to live code this, but I decided I'm tired, so I'm going to go through code I already wrote for this and walk you through it. And the only part that doesn't match up entirely with what we just talked about is, recall how I said that we can post the username and password for sign up on the headers or in the body? And this app, I did it on the headers, on the same authorization one. So on mine, I posted the password on authorization basic username :password. And this username :password is base64 encoded, which is not secure whatsoever. It's just the default way it's done. It's stupidly easy to decode from it. So just one additional step is, instead of just getting the username and password off the body, we're going to decode the password off the header. And I'll go through another example tomorrow where we don't do this. And frankly, both ways are done, so I think it's worthwhile seeing exposure to each one. Okay. So going through this, let me start the recording. Got it? Okay, in my index, I have body parser mounted up, and I have an auth router here, and just one standard route. All my auth stuff is prefixed in front of auth, and comes from this auth router right here, which is an app routes. Inside of that router, all we have is two routes: post sign up and post login. And there's a related controller for each: controller.signup, controller.login. Both of those are post. Any surprises so far? Okay, so I'm going to go over to the controller and look at the auth controller. And we'll go through sign up first. So for starters, I say, all right, if we don't have a rec.body.username or rec.body.password, oh, this one I did do it in the body. I guess you lucked out after all. So if there's not a username and a password on the body, I say error. Username and password are required. Okay. Otherwise, I say user equals model.create rec.body. Rec.body. And model.save the user and respond with it. So looking at the model, I know, right? All create does is, and I did this without a database even to really make things simple, so we don't have to worry about the Postgres parts, is it creates a user basically like a class, except without using class, to not even mix OOP into this, where it takes the username, the password, and it generates an ID and returns it.
We are inside which file now?
We are inside the model.
Oh.
So here,
Are you going to slack this out?
yeah, I'll slack it out too.
Okay.
Yeah, so what we did is let user equals model.create rec.body. And that calls this function right here, where all it did was make an object with username and password. This just adds some structure to it. Like, this could have literally been just trying to make it look a little bit more formal. Okay. Then we save it, which is this function right here. And what that does is it hashes the user password, and then it adds it to the DB. And that's what's kind of complicated about this is it's a pretty clean flow chart when you draw it, but when you actually look at it in the code, there's a lot of jumping around with it. And the checkpoint has a different version of this, so you can see two different approaches to see which one makes more sense to you. I'll post this one up as well. And when we go to hash user password, that's another function defined in this file. And all that is a thin wrapper around bcrypt, where it takes in the user password and the number of rounds of salting we want. Bcrypt is just automatically adding the salt for me. You could generate your salt separately, but by default, if you give it that second parameter, bcrypt will generate the salt behind the scenes for me, so you don't really need to worry about that much. Then what it's going to give me back is the hash password. I overwrite the user's original password with the hash password and returned it. Okay, so we have, let me go to the original part. I'm going to close this one real quick to give us some more room. We had this save function here, where what save does is it hashes our password and saves it to our database. So see right here, it calls the hash user password, which is a promise. Right. Because the reason why it's a promise too is because bcrypt's functionality is relatively slow and complex, so we want to handle it off the event loop. Because if we're sitting there hashing passwords, we can't be accepting new requests in, so that's why we do it on a different thread of the event loop. And after the result right here is going to be that same user object, but with the password property replaced with the hash password. So instead of user.password being password1234, the user.password property here is going to be the hashed one. And then we push that to the database. The details for how I hash that user password, though, is we'd have to go up to the hash user password function. And the hash user password function does bcrypt.hash, passing in user.password. This value hash right here is the actual hash password. And see how I said user.password equals hash. Yeah. Right, I had an object where it was username blah, password blah. And now instead of the clear text password, it's the hash password right there. Yes.
Can you go over the return bcrypt.hash? Where is return bcrypt? Is that like a method right now?
It's the bcrypt.hash returns a promise. That's another part I'll add is for all of this authentication type stuff, passwords are used pretty freely and fluently. So if you're not feeling completely comfortable with promises, you're going to want to go back and do some reviewing of that, because if you're trying to understand promises at the same time you're trying to understand this, it's going to be conceptual overload. Yeah. So if you still need some work on your promises, kind of just gloss over that part and make a note to review it later, because I can't explain both of those adequately right now. Yes?
Can you clarify the salt rounds?
Yeah, so what the salt rounds is, it's just the number of times it's going to salt it. We don't particularly care about that value a whole lot. The API just requires something. And that the salting is still occurring. It's just that we aren't manually generating the salt. You remember how I said in a literal step-by-step process, it's like we had the password, we had the salt, we add them together, and then we hash them. From a programmatic standpoint, it doesn't look like that, because this bcrypt.hash function is going to generate the salt and add the password on our behalf. And this is just saying how many rounds of salting it's going to do, how complex the salt is going to be, basically. Where higher is more complex and secure, but it's also going to be slower. The reason why I made it salt rounds instead of 10 is because if I would put just 10 right here, that's a magic number. No one's going to know what that 10's doing. So instead, because if I were to look at this code, I wrote this code weeks ago. If I were to see a 10 right there, I would have no clue what the hell that 10 meant. I'd have to go check the API docs. But since it was salt rounds, that gave me enough context to remember what it did.
So is it all caps because that would be something that you would put in an environment variable?
Yeah, it's all caps because typically that's something we'd set an environment variable. And it'd be a constant. Okay. So the function then hashes the password, right? Then we go back to our function that called this. Right here's what we called hash user password. And the then block right here is going to run before the then block right here. Just kind of doing a little bit of promise review. And after we get the user with the hash password, we're going to push it into the database. If you're doing next, this would instead just look like not terribly conceptually different. Okay. And at this point, we have, going back to our original drawing, we have the database with our user with the hash password in it. So we're going to go back to the controller, which called this save function. And we're going to respond with the newly created user. And if there's any error during that process, it's going to go to the catch right here, and we're going to pump error into the next and have our area handling middleware take care of it. Is that lining up with what we saw earlier? It's all the same steps, I promise. And I could go over it again if someone wants to see it again, but the one concession I will add to that is this is pretty promise-centric code, and there's not a whole lot I could do about that. Promises are pretty tricky, so it's understandable if you have to review promises a little bit to make sense of this. Does anyone want to see it again?
Yes.
All right. So going back, we have a route called signup. And what will be helpful is I'm going to go forward slowly, assuming you get everything I'm saying. If there's a point where someone's getting confused and wants me to slow down and re-explain or further explain, please stop me. I can't read minds. So we're going to go to controller.signup. That's the function that's going to run when that route's hit. That's defined over here.
Yeah.
I'm going to switch to that file right now. Inside signup, we're first going to verify that the user posted a username and a password. If they're missing either one of those, we're going to say next new error, username and password required. Otherwise, we're going to create the user, save the user, and respond with the user. And in the process of creating and responding to the user, behind the scenes, we're going to hash the password and save it to the database. That's the part I'll go into next. But after it's created, hashed, and saved, we're going to respond with it to let the front end know that this went correctly.
So does the .save function have the hashing part?
Yes, it does. It calls the hashing part on our behalf. We hash it before we save it.
Okay.
Yep. And I'll go into there next. Model.create, all that did is right? It's just to make it look a little bit more like next and be a little bit more structured. That's all it's doing. And save is what's hashing it and putting it in our database. So I'm going to go to that function next. That's in our model. How come I'm doing that in the model and not in the route, by the way? How come I'm not hashing the password in the route?
Because the route is only where you're going. It's telling you where to go. If you do it in the model, that's where all the logic is.
Exactly.
Yeah.
Right? Conceptually, we could have done that here, but it would have been the wrong spot as far as MVC and separation of concerns. Okay, so going over into model, I'm going to go down to the save function. The save function hashes the user password. We'll look at the details of that next. And after it hashes it, it adds it to our database and then returns the user, which is then going to be in our response.json user. And for hashing the password, that's a wrapper around bcrypt.hash, which is going to take the user password and some configuration for the salting. It's going to do the salting on our behalf, though. It's going to respond with the hash password. We're going to overwrite the clear text password with the hash password, because down here, we're then going to push that password into the database. Go back up to the other part.
Go back to the other part. So the return bcrypt.hash, bcrypt is like a library that you're requiring in, right?
Yep, that's up here, and that's what's giving me all my hash functions.
Great. And so then you say bcrypt.hash. I don't understand, like, where's the hash coming from?
So, for one, bcrypt operates in an async manner.
Okay.
Because it takes a while to hash a password, that's a relatively computationally complex process. We only have one main event thread, so that thread can continue to receive requests. We push that off to the event loop, handle other requests, and then once the password's done being hashed, inside of our promise.then, right inside of our callback, here's the hash password.
Got it. So that's the single hash password.
Yep.
And then we're making sure that the user's password that the person has created turns into the hash.
Yeah, at this point, I no longer have track of the clear text password.
That's fair.
Yep.
Okay, so it's just gonna be hash. Great.
Yep.
Okay.
So every time you pass a certain password through bcrypt, it's gonna come up with the same hash.
If we use the same salt, yes. Which, unless we restart the server, it's going to be the same salt. The salt is configured the first time we run it.
But we're gonna keep the same salt so that they can log back in, right? Like the salt's not gonna change.
The salt's not going to change for a while, but these tokens are ephemeral by nature. The idea isn't that a user gets that token and holds on to it forever. The idea is that the user gets that token for the duration of their login. And the salt will stay the same for that duration at the minimum. Probably longer, but not necessarily.
So salt is for passwords and tokens, or just
Only for passwords.
only for passwords?
Yep.
So if the server restarts, does everyone have to change the password?
No, if server restarts, everyone's going to have to get a new token.
Well,
You just said salt's only for passwords.
yeah, you just said salts are only for passwords. So if the server resets, you said the salt will change.
Yeah, it's only for indirectly that's going to happen. Because
Because you store the salted password in the database.
yeah, no, sorry, never mind. Even if you restart the server with that one, it would stay the same. I was getting confused with something else. Sorry.
No worries.
Okay. So we got the password, and frankly, if you were to pretend the whole salting thing didn't exist, and if you were to just say, okay, I always have to put a number right here, you would be technically incorrect, but it would matter surprisingly little as far as an implementation standard goes. Like, I still encourage you to understand how salting works because it's a good potential job interview question, but as far as you coding this up, you could code this up with zero understanding of the salting parts. It's a little bit more in the background on the side. Good to know, but not truly 100% essential. Okay, we go back down to here, add it, return it, and the response.
I feel you.
Any questions on that? All right, so now let's look at login. Logins where we're gonna generate our token and compare the passing username and password against what's in the database. So going back over to routes, for login, we have controller.login. And what login does, oh, here's the part where I did a little bit differently. This is the one where I did use for login, passing in on the header instead. But frankly, if you were to look at this part as instead of this code, same thing is right here. This is just me reading off of a header instead of reading off the body. One way or another, you pluck both those off though. And for those who are interested, I can take a look at this afterward, but for those who are just trying to get by with this, I don't want to confuse with that detail. Okay, so what we do then is we go into model.findUser, where it finds a user that has that username. We'll look at the details of that afterward. Here's our user. If that didn't return anything, right, if it returned undefined because there was no user with that username, we're going to say new error, user not found. Otherwise, we're going to say model.comparePassword, given that user and given the password that we read in off the request, we're going to have this matches value, where if it doesn't match, we're going to return next invalid password. But if it does match, we're going to generate a token and respond with the token. Okay. So I'm going to go into compare password next. But before I go into compare password, what do you all think this function is going to do based on what we said earlier? Without even looking at the implementation, what sort of details do you think you'll find in there? Yeah, so we're going to hash the password and compare it against the password that's stored in the database. Right? We can't just compare it directly because we didn't store the clear text password, we stored the hashed one. So going into compare models.comparePassword, bcrypt actually has a fancy function that will do this for you, where if you do bcrypt.compare two things, it's going to hash it and then do the comparison. Right, just kind of like how bcrypt would add the salt for you. It's kind of annoying because bcrypt's doing things to make your life easier, but as we're going through and trying to understand the step-by-step, it obfuscates some of the steps for you. Behind the scenes though, this compare method will hash in this password and then compare it against that value. Right, so hash this one and compare the hash value to that value directly. That is promise-based. So we're going to .then it after the fact. And that's what this value is right here. This is going to be true if they were the same and false if they were different. If they are the same, we're going to generate a token and return that token. And we're going to generate the token passing in the user.username. Why do you think we're passing in user.username to generate token based on what I said earlier? What are our three parts of a token? We have the type, we have the signature, and what's the last part? The what?
The secret?
Secret? That's part of one of the other part. But the part I'm specifically going for is the payload here. The information that we're custom writing to it. So down here in generate token, jwt.sign, username, and the secret. We'll talk about the secret a little bit more tomorrow. That's basically, I'm super hand waving here, kind of like the salt for when we are doing bcrypt, and that it just adds another factor to this. So if someone got the token, they don't have everything they need for it. You can see here that I just hard coded it to a value. But the important part for today at least is we are, by signing this parameter right here, we are writing that information into the payload of the token. Then we are returning it. Then finally, we're responding with the token. I don't have a front end for this, but the front end would then store that token, and when it wants to do access any authenticated route, it would pass that token along. Making sense?
Okay, I'm a little lost in what, we're sending the response, we're not at the controller, are we?
We're in the controller right now. We're in the login controller. Yeah, high level overview, we're going to get the username and the password off the request. We're going to find a user with that username. we're going to compare the password that we sent against the user's password. Behind the scenes, we're doing that by hashing that password and doing a comparison that way. Then if they match, we're going to generate a token. We are going to bake that user's username into the token as part of the payload. That'll help us do authorization later on. And then finally, we're going to respond with the token.
I think some of us needs to sit with this function.
It's a lot of stuff. And as I said, I'm expecting around like 40 to 50% comprehension out of this just because it's so much stuff.
Yeah.
My idea being if I overwhelm you all with the information of this today and then go over it again tomorrow,
Yeah.
between today and tomorrow, and then doing practice work on this for Monday and Tuesday, by that point you'll have it solidified. Right? This is a hard enough topic that I doubt you're going to get it in one iteration like this, but after 3 or 4 exposures, it will start sticking. I have literally not had a student who has failed to learn authentication. If you've gotten this far in the course, it will be a struggle, but you will get through it. None of you will be the first. I have had students who are far worse than all of you who have managed to get down authentication.
Good job, everybody.
So you can do it.
This is not something we wish.
All right. So what's the third flow that we need to look through in the code? We talked about signing up. We talked about logging in.
Let's see, it's authentication, or is it
Authenticated routes.
It's accessing authenticated routes. And the part where the disconnect I'm seeing, or at least imagining people are having, is it's easy to talk about it conceptually. The part that's hard is you have to get that conceptual model so baked into your code that when I look at this, I don't see code, I see shapes. Honestly, I see that diagram that I looked at earlier. If you think about this in terms of word and syntax, it's too abstract and it's not going to make sense. You really have to build mental models of this stuff for it to really click. If you just think about it in terms of language is not sophisticated enough to describe something's complexity. You need drawings and architecture. Which you all understood earlier. Now it's just the hard part of connecting those, conceptions back to the actual code. Okay, so for our last one, app.use auth. See how here I have auth equals require lib middleware authenticate? That is my middleware that's going to, from the request, read the header and validate the token. Then, given that token's good, we're going to get to this route right here. We don't have any meaningful routes on this. All we're doing and saying is that app.use auth, right? And notice how this came after this. These routes, all the routes we defined here in auth authenticator, are unauthenticated routes. Given we mounted the auth middleware right here, all routes defined after this are going to pass through that authentication middleware. So given that the request passes the authentication middleware, we'll just get back a response that says, welcome authenticated user. Right? What you do after you authenticate the token is very domain/app specific. There's not a whole lot to talk about there. But let's talk about that middleware and see what it does do. It's back. I'm starting to hate this cable.
I talked to the data science people and they said we could take their Apple TV.
Ooh, really?
Yeah.
Ooh, I'll go state that then. Let's do it. So it's a bit of a doozy. But before looking at all the code, let's talk about each of the bits one by one. What's the first thing that we have to do? Don't look at the code, just think about it. What do we got to do first thing? Headers?
Okay.
Right, we have headers. We need to read off the authorization headers. So notice my first chunk of code. Right, I know it's easy to see a wall of code and just panic, but you got this. if not request.headers.authorization, return next new error authorization header missing. What's that doing for us?
Kills the whole thing, right?
Yeah, what that's doing is we're putting this token on a header called authorization. This is checking for the presence of that header. And if that header was not added by the request, it's going to cancel out right here and there. Otherwise, what we're going to do is we're going to get the auth scheme and the auth string off of those headers. See how I did the split based on the space? That looks a little bit weird and random, but that's because, recall, the form of this is bearer or token. Right? We want to get just the token part. So what's the value of auth scheme going to be?
Bearer.
Bearer. And auth string? That's the actual encoded token. In mine, I gave the ability to use basic or bearer. We can ignore the basic one for now. That would just allow people to just send their username and password every single time. Ignoring that, let's say it's bearer. What we're going to do then is say request.token is equal to bearer auth string. Before going to that function, that's going to take that literal string of information and rehydrate it back into a JavaScript object token, put it on the request object, and then go into next. What we could do with that, even though I didn't do it here, is going back to our route that uses this auth middleware. I can say console.log request.token. And all the information from our token will be on there, which can be very useful depending on what you're doing. Then we're calling next and going into that. And if auth scheme didn't match basic or bearer, we're saying error out, that's not a supported auth scheme. Okay, so is everything, ignoring how the token is validated based on this bearer auth part, other than that, is this making sense? Any questions on the code from here to here? So the value of auth scheme is going to be equal to bearer. And the value of auth string is going to be just random garbage, basically. And the value of requests.headers.authorization is going to be bearer space random garbage. And that's just the format of how we do the auth header. Right? This is still, at the end of the day, just a value we're passing up, but we just happen to package it up through a header that's a little bit more complex. That is the form auth type space value. And that's what we're pulling out right here. That's all this is doing, is it's using a fancy ES6 destructuring with a split, but really it's just turning this string, bearer space auth value, into two separate strings like that.
In an array.
Yes. Well, no, it's individual values for each. This isn't an array, it's a destructuring.
Oh.
Yeah, another way, if that's throwing people for a loop, is you can look at like this. Is the longhand version of what that's doing. Yes.
So where would we put this authenticator middleware so that it only applies to routes that need authentication and not routes that won't have any, like the sign-up route?
Sure. So whenever you put app.use and don't put any routing information, you just put a middleware. Any routes declared after that are going to use that middleware. So you just have to use app.use auth router after you declare all of your unauthenticated routes. And I could flip back to the other page and show you that in a second. Okay. You can frankly ignore the switch part and pretend that we're just doing this code right here. The switch auth scheme yada 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 isn't so important if you're only doing bearer. So assuming we have auth scheme bearer and more importantly auth string equals this garbage, we want to turn that garbage back into a JavaScript object that we can do something with. That's what this is doing. We're decoding the auth string into our original token, mounting it to request, and going next. You can ignore, again, all the stuff in the switch statement. That's only for supporting multiple auth schemes, which isn't necessary. Yes?
Why do we have two cases in there? Because I mean, what's an example where, yeah, I know what the two cases are, but like if we're writing the back end, we know what type of token we're delivering to the front end.
So this particular backend, which is not something you're going to need to support, but many backends do support, such as the GitHub one, which is why I wanted to expose you to this, is for any authenticated route, a user can either provide a token on the header, or they can provide their actual username and password on the header.
Or you can leave that choice up to the user.
Yeah, you can leave that choice up to the user. So this is just for added flexibility.
Okay.
You don't have to do both. So basically, with this extra auth schema setup, someone could skip the login process and just post their username and password every time with their password, with their login. Yeah. One's back. Okay. So the next part we have to do is just figure out what this bearer auth function is doing right here. I don't know what's up with that projector. And this is really simple. All it's doing is, recall how before we did model.sign token. Now we have model.verify token that just turns the string into the actual token. And this function right here, we can take a look at it. It's just a wrapper around the JSON web token library that we use to sign it. So if we go over into model user, right, we're calling model.verify token. All it does is call JWT verify, passing in that token and the same secret we use to sign the token. Then we return the token, return it back, come back up to here, put it on request.token, and we're all authenticated. Okay, that's a lot of stuff. And again, what I really recommend doing is taking this code, browsing through it tonight/tomorrow at your own leisure, and really going through and understanding it line by line. And then additionally, what can be helpful is to actually send some HTTP requests to the server, try using it out. Then furthermore, you can try setting some debug points in it and actually walking through this, right? All we can do at this point really is walk through and re-explain the code. It's going to take a certain number of repetitions before it sticks in your head. And I think those repetitions are a little bit easier at this point with a debugger and you looking at it yourself. So I'm going to post this code up to GitHub for you all.
Thanks.
But any questions before I tear down the projectors and burn them?
And the secret behaves the same way Assault does, where you just assign the same secret for every user?
Yeah. Yeah, that's really just to prevent the problem of, let's say I stole a Patrick's token. Given that a different server instance might assign to his, because you're probably going to have multiple backend servers doing this really, right? He might have gone to this one, and I jacked this token, and I'm trying to use it on this server, because I don't get to choose what server I want. Well, that server signs it with a different secret. And we'll go over that part, right? If there's one part you're going to choose to ignore and not understand today, I would say that make it the secret part and the salt parts. You want to get those down eventually, but those are not really required for a first pass of understand this. So I would suggest, if you're feeling overwhelmed, to just completely ignore the salt and secret part. Just kind of take that for granted. And then after you're feeling more comfortable with the other parts, then work them back in. Also, too, being conscientious and courteous to yourself. You've just been in lecture for about like 3.5 hours now. So you're probably running out of steam. So if you're starting to not get things and things aren't sticking at this point, that's quite reasonable. we'll be going over again tomorrow. All right.